Hello everyone, this is Chandan and you are watching the learning field. Hope all you are doing well. So this is the lecture 7 of our numerical analysis lecture series. Okay, and in this lecture series we will discuss the Hermite interpolation and some parts of, and a small discussion of cubic spline. Okay, because these two interpolation formulas are very important interpolation formula, that's why we take or we did these two interpolations. Okay, so and one more thing is that this is the 7th lecture series, and you get all the lecture series of the numerical analysis lecture series for GATE, CSIR, NET and Hermite. We already discussed that this lecture series is specially based on GATE syllabus, but it is also helpful for CSIR, NET and SET and any Hermite exam in which the syllabus of the exam are numerical analysis included. Okay, so in this lecture series we will discuss the Hermite interpolation. Okay, and one more thing is that I upload some videos of numerical analysis, or I take some classes on live and I upload some videos on recorded. Okay, so that's why I always suggest you to go to the playlist section, okay, of the channel page. Okay, because in previous the live classes and the recorded classes on YouTube are in a single column. Okay, suppose this is the channel page, this is home, दिस इज वीडियोज, दिस इज लाइव, ऐसे करके कुछ है, ठीक है, एंड दिस इज द कम्युनिटी टैब एंड बहुत सारे कुछ है. तो वीडियोस एंड लाइव सेक्शन पहले जो था एक ही था, बट अभी जो है वीडियो सेक्शन एंड लाइव सेक्शन दो पूरा के पूरा दो अलग अलग मतलब कॉलम बन गया है. ठीक है, तो यहाँ पे आप लोग आई ऑलवेज सजेस्ट दैट प्लीज गो टू द प्लेलिस्ट सेक्शन, एंड यहाँ पे एक प्लेलिस्ट करके भी है. ठीक है, तो प्लेलिस्ट सेक्शन में जाके न्यूमेरिकल एनालिसिस सिलेक्ट करो तो पूरा के पूरा 1 to लेक्चर सीरीज जितना मैंने लेक्चर यहाँ पे दिया हूँ तो पूरा के पूरा लेक्चर्स मिल जाएगा 1 by 1. ओके, सो दिस इज माय रिक्वेस्ट. सो लेट्स स्टार्ट, एंड बिफोर स्टार्टिंग आई एम रिक्वेस्टिंग यू दैट दोज हु आर न्यू एंड दोज हु आर watching me for the first time, those who are new in the channel, so please like, comment, share and subscribe the channel. Okay, so let's start. So what is the Hermite interpolation? Okay, so the Hermite interpolating polynomial interpolates not only the functions fx but also its derivatives at the given set of tabular points. Okay, so in the values of the functions, that means what this Hermite interpolation interpolate the function fx and its derivative terms also f dash x. Okay, so the function y equal to fx and its first derivative are known at n plus 1 points, then it is possible to determine an interpolating polynomial by interpolating polynomial. Okay, suppose and we take the interpolating polynomial phi x in the previous calculation, so we here also take the interpolating polynomial, the polynomial which have to be determined in this phi x. Okay, is this phi x? Okay, so such that phi of xi equal to fxi, that is what this function and these functions are equal at any point xi, and phi dash xi equal to f dash xi for I equal to 0, 1 to n. That means there are n plus 1 interpolating or the given data values. Okay, so this formula is known as the Hermite interpolation polynomial formula. Okay, now here the number of conditions is 2n plus 2 and the number of coefficient is to be determined here is 2n plus 2 because there are 2n plus 2 conditions. Okay, and the degree of the polynomial is 2n plus 1. Okay, so these are very important things, very important things you can say regarding this formula, regarding this formula. Okay, so let us consider the Hermite interpolating polynomial formula in the form phi x equal to this summation I equal to 0 hix fxi plus summation I equal to 0 hix plus f dash xi. That is, this is for the normal term fxi, and this term is stands for the derivative term, that is fxi, and the coefficients are small hi and capital hix are the coefficient of fxi and f dash xi respectively. Okay, where hix and hix are I equal to 0 to n are the polynomial in x of degree at most 2n plus 1. Okay, so by 1 we can write, by 1 means this one, this is 1. Okay, so this is 1, we can write by satisfying this phi x we get hi xj, this is equal to 1 for I equal to j and 0 for I not equal to j, and here hij is equal to 0. for this case. Okay, for this case hix, capital Hix is equal to 0, and for the second term we get h dash ixj, this is equal to 0, and h dash xj, this is equal to 1 for I equal to j and 0 for I not equal to j. We just put the values phi x to the to this equations 1, okay, phi xi and phi dash xi, and get these conditions. Okay, conditions, these are the condition number 4. Okay, these conditions we working on that. Okay, so now let us consider the Lagrangian function Lix. This is equal to this is the Lagrangian function x minus x0, x minus xi minus 1, x minus xi plus 1 up to x minus xn by xi minus x0, xi minus x1, xi minus xi minus 1, xi minus xi plus 1, and this we all know that this is the Lagrangian function. Then obviously Lixj, this is equal to 1 for I equal to j and 0 for I not equal to j. Okay, this is suppose number 6. Okay, since Lix is a polynomial of degree n, then the Lix square is a polynomial of degree 2n. It is very obviously true. Okay, again Lix and Lix whole square both satisfies the equation 6, that is this one. Okay, this is the difference in Lix and Lix square is only in the degree. Okay, this is of degree n and this is of degree 2n, and these both polynomials satisfies this condition 6. Okay, since Hix and capital Hix polynomials in x of degree 2n plus 1, their explicit form may be taken as Hix equal to ai plus aia into x plus bi into Lix square. That is what, this is the degree 2n, this is of degree 2n and this is degree 1. Okay, so that is 2n plus 1, this Hix and capital Hix are all degree 2n plus 1. Okay, so a capital Hix equal to Cix plus di into Lix. Now we have to find these coefficients ai, bi, ci and di. Okay, so condition 4, from the condition 4, what is the condition 4? This one. Okay, so this one is the condition 4. So from condition 4 we get aixi plus bi equal to 1, cixi plus di equal to 0, ai plus 2 li dash xi, this is equal to 0, and ci equal to 1. You can verify that by putting the values. Okay, so this relation gives ai, this is equal to minus 2 li dash x, and bi equal to 1 plus 2 xi into li dash xi, ci equal to 1, and di equal to minus of xi. Okay, hence hix, small hix, this is equal to minus 2xi. We just put the values ai and bi in the given equation of hi here. Okay, so this one in the equation 7 we get hix equal to 1 minus 2 into x minus xi into li dash xi into Lix square, and hix, capital Hix, this is equal to x minus xi into capital Lixi whole square. Okay, so we get the values of capital Hix and small hix. Now we put the values of capital Hix and small hix in this equation phi x, that is in equation 2. Okay, so putting in equation 2 we get what? We get phi x, this is equal to this one, 1 minus 2 summation I equal to 0 to n 1 minus 2 into x minus xi l dash xi into Lix whole square into fxi plus this term, and this is the required Hermite interpolation polynomial formula. Therefore we construct the Hermite interpolation polynomial formula. You don't need to construct the polynomial interpolation formula, you just remind this formula. Okay, this is, you can take any, the name of the function main you can take as your choice. Okay, so this is the main formula where what these Lix are the Lagrangians. Okay, and fix are the given what values at the point xi. Okay, so this is the Hermite interpolation formula. Now if we take an example, so determine the Hermite interpolation polynomial of degree 5 which satisfies the following data. This is the given data table, and find the approximate value of cube root of 2.8. Okay, so from the given data we first find the Lagrangian functions. Okay, so L0x equal to, this is the formula, so x minus x1 into x minus x2 by x0 minus x1 into x0 minus x2. So this is the x0, this is the x1, and this is the x2. Okay, so we just put the values and calculate this L1, L0, L1 and L2. Okay, so L0 equal to this one, L1x equal to this one, and L2x equal to this one. Okay, now we find their respective derivatives of L0x, L1x and L2x. Okay, so these three are the derivatives of L0, L1 and L2. Okay, and L0 L dash 0 at x0, this is equal to 0, that is x0 is equal to what, 1.5, and L1 dash x1, this is equal to 0 because the remaining terms are 0 in the summation term by the definition of Lix. Okay, you can check that because I think Lix, this is from this definition, just a minute, this one, Lixj equal to this one, this is the definition. This is only valid when I equal to j. Okay, so this is a formula. So Li x2, L2 dash x2 and L2 dash x2 and L1 dash x1, these are the three values. Now we calculate the h0x, h1x and h2x by using the given formulas. What is the formulas? These are the formulas. Okay, so hix and capital Hix. Okay, these two are, by using these two formulas we calculate what? We calculate the capital Hi's and small hi's. Okay, so capital H0x is equal to this one, and L0x means is what? This is here 4x minus 9. Sorry, L0x means here this one, 2x square minus 9x plus 10. Okay, so just put the values. So this one is equal to, we get 6x minus 8 into this whole square term. Similarly, we calculate a small h1x by using the given formula and h2x by using the given formula and get the values. Okay, now we calculate the capital H0s. So capital H0x equal to x minus x0 into L0x's formula. The explicit or the formulas of Hix are already given. So we just calculate the values by putting the x0 and x1 L0. Okay, so h1x equal to this one and h2x equal to this one. Now we put these values in the main formula. Okay, what is the main formula? The main formula is this one. Okay, so we break the summation and put the values of respective Hix, capital Hix and Xi's and Fi's. Okay, so we get this total formula for phi x after breaking the summation. Okay, so you just check it, this is very easy, just put the values in the given formulas. Okay, so now to find the values of this one, we put x equal to 2.8 in this expression. Okay, and if we calculate, then we get the values cube root of 2.8, this is equal to 1.40948. Okay, so this is the example of Hermite interpolation polynomial formula, and I am thinking to take 2 classes for the both Hermite interpolation and the spline interpolation, but I then think that I take 2 classes in a single class. Okay, because these two are very big, so that's why I think this class going to going something long. Okay, going some long, okay, a long time. Okay, so now we start with spline interpolation. Okay, so what is the spline interpolation? So spline interpolation is a very powerful and widely used method and has many applications in numerical differentiation, integration, solution, and by a boundary value problem and so on. Okay, the various methods of numerical analysis we need spline interpolation, or we can working on that dependent on that. Okay, so spline interpolation method interpolates a function between a given set of points by means of piecewise smooth polynomials. Piecewise smooth polynomials means differentiable number of times as you can or as you need. Okay, that means these are continuously differentiable, you can say smooth polynomials means. Okay, so in this method the curve passes through the given set of points and also its slope and its curvature and the curvature and continuous at each point. Okay, so this is the spline interpolation. You can the introduction to spline interpolation, just some talk. Now we comes to the main thing, which is cubic spline. This is the most important thing of the spline interpolation. Okay, so a function is called cubic spline in x0 xn, or if there exists cubic polynomials p0x, p1x and pn minus 1x such that yx equal to pix on this interval, pi minus 1 into I dash xi, this is equal to pixi. This is the conditions for equal slope, and the third one is equal curvature, that is pi minus 1 double dash derivative at the point xi, this is equal to pi double derivative at the point xi. This is I minus 1 and this is xi, that is equal curvature. Okay, and pixi equal to yi and pixi plus 1, this is equal to yi plus 1, I equal to 0, 1, 2 up to n minus 1. Okay, so this is the definition of cubic spline. Now here I am not going to the construction of the cubic spline. I just write the formulas and we solve an example from the book. Okay, so this is the content, because if we going to construct the cubic spline formula, then this is a very big calculation. Okay, that's why I skip this. Okay, and you can see the formula formation in the book. Okay, so the interval is xi and xi plus 1, I equal to 0 1 to n minus n with the ith interval, hi equal to xi minus 1 and mi equal to y double dash at the point xi. Okay, then the cubic spline polynomial, this is equal to 1 by 6 hi into xi minus x, that is this point which has to be interpolated. Okay, xi minus x and xi's are the given data value. Okay, and xi minus x whole square minus hi square into mi minus 1 plus 1 by 6 hi into this one, this term, and then 1 by hi into this term, then 1 by hi into these terms. Okay, now here some terms including mi. How can we calculate this mi minus 1? Okay, so for this purpose or to calculate these mi's, we need this relation. Okay, so which is equal to hi by 6 mi minus 1 plus hi plus 1 by 3 into mi plus hi plus 1 by 6 into mi plus 1, and this is equal to, we can write 1 by hi plus 1 into yi plus 1 minus yi plus 1 by hi into yi minus yi minus 1, this relation. From this relation, because these are the given values, okay, yi's at the point xi's are given given in the tabular form, so we can and hi is also known, therefore we can calculate the relations between mi's, and then we need to solve the relations to get the values of mi's and put the values of mi's to here. Okay, this is the calculation, and this is a big calculation, you can say. So this is a system of n minus 1 linear equations in n plus 1 unknowns, this m1 m0 m1 to mn. Okay, two additional conditions may taken in one of the following forms. Okay, so from including these conditions, you also need these two conditions, either this case, and in this case m0 equal to mn equal to 0, then this spline is said to be natural spline, and m0, this is m0 equal to mn and m1 equal to mn plus 1 and y0 equal to yn, y1 equal to yn plus 1 and h1 equal to hn plus 1. If these conditions are satisfied, or if you need this type of these conditions including the above conditions, then this is called periodic spline, or I think you should provide in the exam the types of spline. Okay, this case also may be happen, and this is equal to f dash a equal to y dash a equal to y dash 0 and f dash b equal to y dash b equal to y dash n, not periodic spline. Okay, where this ab is what? Ab is the interval in which the three functions, that is fx, f dash x and f double dash x are what? Are here the continuous functions. Okay, now this is the most important thing is that this is very important for equispaced nodes, that is hi equal to h, that is the all nodes are equal for all I, then this is the formula. Okay, and based on this formula we solve a problem. Okay, so fx equal to 1 by 6h into xi minus x whole cube into mi minus 1 plus x minus xi minus 1 whole cube into mi plus 1 by h into xi minus h into yi minus 1 by h square by 6 mi minus 1 plus 1 by h into x minus xi into yi minus h square by 6 into mi. Okay, this is the function, and to calculate the mi's from this relation, mi minus 1 plus 4 mi plus mi plus 1, this is equal to this term. Okay, so this is the polynomial formula, and to calculate this polynomial formula we need this mi's, mi minus 1 terms. To calculate this formula we get this, or from this relation of mi's and yi's, because these are the given values, we calculate the value of this mi's and then put the values here. Okay, so if we take an example, suppose if we take this type of example, suppose x and fx. Okay, x and fx are given, some points are given, so 0 1 2 3. Okay, since we already see that these are equispaced. Okay, so this is 1 this is 2, this is 33, and this is 44. I take a standard example from book. Okay, with m0, that is m at 0, this is equal to 0, and m at 3, that is m3, this is equal to 0, and hence find an estimate of f of 2.5. we need to find this one. Okay, so if we apply the method, then we first see what is the value of h. Since this is equispaced, therefore h equal to 1 from this. Okay, we can write, and the relation between the mi's is mi minus 1 plus 4 mi plus m I plus 1, this is equal to 6 into y I plus 1. These are the yi's. Okay, yi plus 1 minus 2 yi plus yi minus 1, I think. Okay, for I equal to 1 and 2. Okay, because this is y 0, x0, x1, x1, x2 and x3. Okay, so we calculate up to I equal to 1 and 2, then we get the value y3. Okay, now therefore if we put this value I equal to 1 and 2, then we get two relations. What the two relations are? m0 plus 4 m1 plus m2, this is equal to what? 6 into y2 minus 2 y1. I don't get time to make this PPTs. Okay, for taking this class, plus y0, this is equal, and one more thing, if we put I equal to 1 here, and for I equal to 2, we get the relation what? m1 plus 4 m2 plus m3, this is equal to 6 into y3 minus 2 y2 plus y1. Okay, see, based on 1 values we get 1 values. Okay, so this is the case. So what, and this is the, I think, the natural spline. Okay, this is simple natural spline. Okay, that's why we put what? m0 equal to 0 and mn equal to 0, because these are given in the question. Okay, these two are zeros, that is, this is the natural spline. mn means here what? m3. Okay, these two values are 0. Okay, so we get, now we put the values of this simply. Okay, from the table yi, this is y1, this is y0, this is y1, this is y2, and this is y3. So putting the values of this, we calculate the values of mi's. Okay, so 4 m1 plus m2, this is equal to what? 6 into, you just see, check it once. Okay, minus 4 plus 1, this is equal to 180, and m1 plus m2, 4 m2, this is equal to what? 6 into 2, 44 minus 66 plus 2, this is equal to 1080. Okay, so this is two equation with m1 and m2 and two unknown m1 and m2. Okay, so if we solving, then we get m1, this is equal to what? Minus 24, and m2, this is equal to 276. Okay, so we get the values m1 and m2. Now on the interval is what? We take 1 by 1 interval, 0 1 1 interval, 1 2 1 interval, and 2 3 1 interval. Okay, so we need to find in this interval. Okay, so on 0 1 interval, okay, fx equal to what? We just put the values in the given formula. What is the formula? This is the formula. Okay, so xi minus h, xi means here I equal to 0 here, that means x0 minus x, and x0 means what? X0 means here 0. Okay, so just check it once. I just calculate one thing. So this is equal to 1 by 6 into 1 minus x whole cube into m0 plus x minus 0 whole cube into m1 plus 1 minus x into y0 minus 1 by 6 m0 plus x minus 0 into y1 minus 1 by 6 into m1. Okay, this one. Therefore if we just put the values and simply calculate, then we get 1 by 6 into x cube into minus 24 plus 1 minus x plus x into 2 minus 1 by 6 into minus 24. Okay, if we simply calculate this one, then we get minus 4x cube plus 5x plus 1. So this is the spline in the interval, this one. Okay, and we need to find what? We need to find the value of 2.5, but the value 2.5 lies which interval? In this interval. Okay, if we need to find any point in between 0, 1, 1, suppose we find or we find the value f 0.5, then this is enough for our calculations. We don't need to go proceed further. Okay, but the point, what? The point 2.5 lies between what? 2 and 3. Therefore we go to, or we proceed further interval, or we find the remaining interval also. Okay, that is what, just a second, slides are done. So this is, I just write the just a second. Okay, I think all you are see my slides. So this is the last line, and now if we calculate on the interval 1, 2, okay, so on the interval 1, 2, we get here fx equal to what? Fx equal to 1 by 6 into what? 2 minus x whole cube into m1, okay, plus I just write in the formulas, whole cube into m2 plus 2 minus x into y1 minus 1 by 6 m1 plus x minus 1 into y2 minus 1 by 6 into m2. If we put the values, then we get simply here, from here we get what? We just put the values, from here we get 50x cube minus 162 x square plus 167x minus 53, this one. And similarly, if we calculate on the interval 2, 3, the formula like this, fx equal to 1 by 6 into 3 minus x whole cube into m2 plus x minus 2 whole cube into m3, I think, yes, plus 3 minus x into y2 minus 1 by 6 into m2 plus x minus 2 into y3 minus 1 by 6 into m3. Okay, and we all know the values, required values. Okay, so this is equal to what? Minus 46 x cube plus 414 x square minus 985 x plus 715. Okay, now since 2.5 lies between in this interval 2, 3, therefore we use this polynomial, or this polynomial spline function for calculation the above formula, that is f of 2.5, this is equal to what? Minus 46 into 2.5 whole cube plus 414 into 2.5 whole square plus, sorry, minus 985 into 2.5, okay, plus 715, and this is equal to 121.25. so this is the required answer. Okay, now one more thing is that here one thing is also noted, that is what? That is, if we need any point, the value at any point, suppose f at 1.5, then this is not required. Okay, we just calculate up to this interval, and since 1.5 lies between in this interval, therefore we calculate the values of 1.5, okay, by putting the values of x equal to 1.5 in this function or spline function. Okay, so this is the rules for cubic spline. Okay, so this is the class for today. I think this class is very helpful for you. Instead of these two, interpolation are not in GATE syllabus. Okay, interpolation are not in GATE syllabus actually, but these are in the syllabus of CSIR and NET. Okay, that's why I take these two interpolation, that is, one is spline and Hermite. Okay, so if this lecture series is helpful, then please give a like to this video, share it with your friends, and subscribe the channel. Thank you friends, see you again in the next video. Thank you.